Welcome to 2020 question A2, and this question is very similar to one that came up in 2016 where we were looking at a flip chart and a bar graph. Okay, so the image below shows a drawing board and two set squares. Okay, so we can see that there. The drawing on the right shows the plan and incomplete elevation of a similar drawing board with a 60-30 set square and also a 45-degree set square. Complete the elevation of the drawing board and two set squares. So some of the outline is there. Done first, I'm just going to go over that just to give us a base to deal with. Okay, so that's the outside there and a running across. Okay, so the base behind this question is we need to realise that parallel lines appear parallel in all. If two lines are parallel, they appear parallel in all views. Okay, so we can see here we have a number of parallel lines. So I have the edge here of the board is parallel with this edge of the set square, similarly to here and here. So parallel, 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 and I'll be able to use parallel lines to find this line here. Okay, so we'll start with that. I have my lines coming up. Okay, the base here is parallel to the edge of the set squares. So same here, I have a horizontal line for the base, and these are horizontal running across. So that will find the base there. Next up, like I said, parallel lines here and here are parallel, so I can run parallel to the edge there from that corner. Okay, so that's going to be the angle there at the back, and then that will allow me to join up this 45-degree set square. And I'll actually also join up this part. Okay, so the outline of our set squares are done. And after that, like I said, we're dealing with parallel lines, so I can project the width of this up. I have the height of it because it's going in line with that one there. And that is projecting up and will be parallel. So this edge here is parallel to that. So likewise, I'm going parallel okay, and then finally, right, I actually have the 2 points there determined, but just to show you it's parallel, I'll use my sliding set square to show that. So running parallel to my 6-degree line, I come back here, yeah, those are all in line. Okay, and then finally the inside there of my 45-degree set square. Project that up. That's already projected up. So running parallel to the edge, to the side. And I can join that back, and we'll see that that is parallel also. Okay, so that is the projections of everything there. Okay, a line from point A is drawn on the surface of the board. So there's a line going to be drawn from, let's say that's A on the board. Okay, and it's going to be drawn and has a true length of 55 millimeters and makes a true angle of 45 millimeters or 45 degrees with the bottom edge of the board. So we're going to have a line. The true length of that line is going to be 50, and the angle, the true angle there, will be 45 degrees. Now, we know that we're not looking at this surface or this surface at a perpendicularly, it's sloping away from us. sloping up here and sloping back there. So we need to think about that. There's not really space to determine the true shape of the entire board. So what we're going to do is we are going to use another method. So I suppose this measurement of 45-degree angle, okay, we have seen that already with our 45-degree set square. So using the knowledge we know, or we've used already, parallel lines appearing parallel in all views. So this is a 45-degree angle. A is at, this line that's created is at 45 degrees as well. Alright, so what I can do now is I can't measure that 50 on that line because it's, this surface is sloping, and I can't just project it up and measure it there either. So what I'm going to do is I'm going to rotate this line around so that when I see it in elevation, it's going to be a true length line. So get that distance, rotate it around. Okay, so I'll just indicate that's well done there. And project that up. So that line is a true length line. Okay, I'll just even show it lightly in yellow. So that's a true length line. Okay, so now I can bring in my 50 millimeters. I can measure 50 mil down along that line from A, 50 mil. Okay, so here we have, sorry, I forgot to show this line in elevation. So that is the projections of that 45-degree line. And parallel again. So I should have shown that immediately. So once I've measured my 50, what I can do is I can rotate that, I bring that 50 mil down onto my view, onto my section here, or onto my line that is being rotated, and all I'll do is I'll rotate it back. Okay, I'm just going to indicate all of that. So this point, brought it down, and rotate it back. So here's that point, and I will project that up to my elevation. So that is a line that is 45 degrees because it's parallel to my 45-degree set square, and I've sorted out the measurement there by getting true length of that line, finding it, so I can measure that set true length, and then brought it back and rotated it back onto the view that I wanted. So here's my 50 millimeter line. Okay, so that is question A2 2020. Some problem solving there in the second half of that, but the first half you just need to realise parallel lines are parallel in all views.